One of the leading technologies in the hopes of achieving interstellar travel is the solar sail. Now, a solar sail is comparable to that of a wind sail, the type of sail that's found on sailing boats all around the world, and it works utilizing the same physical laws. As we might know, a wind sail uses the pressure force of the wind acting against it to propel the boat it is attached to forward. And the solar sail works in exactly the same way. But the question is, what replaces the wind in outer space? The sun and every other star in the universe is a raging furnace of attainable energy. At every moment in time, the sun is producing energy through the process of nuclear fusion, where the most common fusion reaction is that of hydrogen to helium. In simple terms, and to not delve too deeply into physical chemistry, this common type of nuclear fusion involves the joining, that is fusion, of hydrogen nuclei to form a single helium nucleus. And since the combined mass of the hydrogen nuclei is heavier than the final mass of the helium nucleus, there is some amount of matter or mass left over, and this is the energy. The fusion of hydrogen to helium is the most common reaction, as these are the two most abundant elements in the universe. The solar energy released from the sun is called solar radiation and can be thought of as particles that carry momentum. It is these momentum-carrying light particles that will be our space wind and our propellant for our solar sail. Therefore, a solar sail utilizes solar radiation pressure pushing against the sail to propel the spacecraft forward. And spacecraft that use solar sails have no need to carry any onboard propellant, which can save valuable mass, a major issue with current rocketry. The idea of the solar sail has been around since the mid-1920s, when Friedrich Sander wrote, "For flying in interplanetary space, I am working on the idea of using tremendous mirrors of very thin sheets." In time, the technology matured, and NASA utilized solar sailing on their Mariner 10 mission in 1973. And by 1978, after more development, solar sailing was declared ready for use on future NASA flights. Major engineering development was seen in the 1990s with Russian tests of a solar sail, followed by on-the-ground German experiments of a stabilized solar sail system. With the turn of the century, progress continues with NASA and privately funded missions. In 2010, Japan's Icarus probe makes great progress and verifies solar radiation pressure effects, while also experiments with spacecraft attitude control using a solar sail. This was quite significant, as in previous flights, attitude control had to be performed via the traditional reaction control thrusters. More recently, in 2017 and 2019, the flights of Inflate Sail and Light Sail A have demonstrated effective methods of compressing a solar sail to an extremely small volume for launch. And experimentation will likely continue in this area in 2023 with the flight of NASA's Advanced Solar Sail Composite System, which will deploy an apartment-sized solar sail from a toaster-sized spacecraft.